All right, good afternoon. So it's time for a couple saw build updates. Haven't made a video in a while. Just going to let you know what's going on here. First, this 372 X Torque hybrid. Really put this one on the back burner while I've been working on some of these other saws and doing these other projects. I just kind of was tired of dealing with all these little problems with this thing. Here's the way that I've solved this trigger not working, just a piece of foam in here. That's just really a temporary thing, but this trigger versus OEM trigger that I felt in the store, you know, on a 372 X Torque, there's no comparison. So I don't really like that about this one. Maybe if this saw proves to be a good runner, I may just find a used OEM tank handle here and just dye it black. Hopefully it accepts dye, so I have a decent handle. If this saw proves to be a good runner, then it deserves to get, you know, that addition. Need to do a pressure vac test. The problem with doing a pressure vac test is I went in here with initially a pick to try to pull this seal out, but as I remember, this seal, I had to press it in, like hammer it in, so it's pretty tight around here. And when I went to try to pull this one out to pop a new one in, because this is where I thought that it was leaking, or you know, that the air leak was, is I've damaged the seal now. Then I bought this tool thinking that this Husqvarna tool was going to be able to pull it out. That's what it's for, seal puller tool. This does not work for these Farmer Techs. You cannot use the OEM crank seals on a aftermarket case because the diameter here, the OD, is different, or the ID of the case is slightly bigger than the OEM ones, I assume, because I bought two OEM seals and couldn't use those, so I used these ones here from the Duke. I don't think there's anything wrong with these. They look pretty high quality. Everything I've bought from the Duke has been fine so far. Pistons, cylinders, any little stuff like that. So the quality of his aftermarket stuff is good. The other thing is, I mean, this saw ran okay with my 20 degrees of blowdown, you know, 78 intake, 122 transfers, 102 exhaust, you know, 20 degrees of blowdown. But now thinking about it and kind of, you know, getting a couple more saws built under my belt, I've realized that more blowdown works better for my style of porting. So when I pull this thing apart, that's really the only way I can figure to put new seals in it. I may just go ahead and swap the crank again to that aftermarket crank that came in this saw, and then just put another 064 connecting rod on it. That's probably what I'm going to do, just to be sure, because this crank here, I think the reason why it was for sale on eBay was because that it was blowing this exhaust side seal, because somebody had ran the chain too tight for too long on this specific crankshaft. That's what I think is going on, because I couldn't get it back to being perfectly true. No matter, you know, I was just, you know, better, worse, better, or just, you know, just be worse one way, worse the other way. Couldn't get it, you know, less than 7 thousandths of run out. So I'm gonna probably do what I just said there, try that other crankshaft with another 064 connecting rod, and see if that solves this issue. With the oil pump, so my oil pump was leaking on here, and I mean, the saw sounded pretty good out of the wood, but once I put it in the wood, it was not, I mean, it was just like a regular, you know, at best, just a regular ported 460 or whatever. And I'm being a little bit generous. I was not that impressed with how it ran. The reason that it wasn't running or didn't feel that powerful is because this oil pump was leaking. So a design flaw with this saw, I don't know if you want to call it a design flaw or just an oversight, is that in order to put the oil pump in correctly and keep your seal here good, everything good, you need to take this band out. Is the only way I see that you can do it well, because you got to get this hose here farther out, and this brake band kind of blocks it. So maybe I can just slightly move it up here a little bit to get the oil pump in there. I'm not sure, but I think I'm probably just going to run it with no oil to begin with. I might do that, I might not, just to see how much power that it's going to have, you know, without running the risk of another oil pump leaking and, you know, dealing with all this. That's just one thought there. I don't know how hard that is on the pump to run it with no oil, but The other thing I'm going to do is I'm going to increase the blowdown. I'm going to try to relieve a little bit of compression and increase the blowdown by cutting a relief in the exhaust side of the piston. Pretend that this is a piston. I'm just going to chuck it up in the mill and just machine off the edge to lower the compression a little bit. I feel that it's a little bit too high, and to give it more blowdown. I feel that that's worked pretty good in some of my other saw builds, so that's what I'm going to try here, you know, and kill two birds with one stone. So hopefully I'll have time in the near future to be working on this one, but some other projects that I'm working on. So this 660 cylinder, I kind of screwed up here and ground through on the intake side here when I raised my transfers, made them a little bit bigger. I think I'm going to have to enlarge this side of the lower transfers without grinding through. So I'm going to use my little caliber tool here with long, you know, ends on it to make sure I don't grind through that side, but increase that guy a little bit to offset for how much bigger I made the upper transfers. I don't feel that that was necessary. That's just what I did, and looking back now, that was not the best idea. So I'm just going to put some JB Weld in here. I've already ground it so that the JB Weld should stick well to it. I've had to do this before when I did my 661 cylinder, and it has held up fine. So I just slightly ground through right here. You can see it down in there, and you know, it held fine. The cylinder doesn't even get that hot out here. I don't know what the exact melting point is, but I think it's like 600 degrees or something like that. So JB Weld will work. It's not ideal, but that's what it was on this one. You can see there's JB Weld in the floor of the intake on this one. Since I had a 2100 piston in it, I had to do quite a bit of work to get that to work. So on to this 661 project. I've got a second, an additional cylinder, a decently used 661 cylinder. I've got an aftermarket case here from the Duke. And the reason for buying this case is I want to experiment with making these lower transfers bigger, so there's less of a pressure drop from the lower transfer to the upper transfer. You can see that, I mean, just my guess would be that, you know, the upper transfer size is about double of what the lower transfer is. So I think, you know, based off of kind of some of these other ones, I would think that making this bigger here, you know, I'm not going to split the case on my saw, but I'm going to use this as my template. I'm going to fill this area here with JB Weld, you know, grind it just like what I've done here, fill this area with JB Weld, and then widen that out on this, you know, this sacrificial case, and then match it with the other one, do the same thing, and hopefully get a little bit more power out of my 661. That's my hope. Get away with a longer blowdown, but you can I'm kind of curious as to how close that this is. I don't have any bolts for it, but yeah, it looks, I guess, fairly close here. So we'll see how much I can widen these lower transfers. There's plenty of material in here. You know, you could probably bring them out, you know, kind of shape them like this, but having that initial area bigger just to get a little bit more flow. And I can use one of the, like this cylinder here. Didn't run that good. I was not that impressed with it. I think the compression was a little bit too high. But I had a little mishap when I cut the base. The lathe that I was using was a little bit too small to cut a rectangular cylinder base, so it was kind of chopping, and then I had to put it on a better lathe, and then, you know, take all the mistake out. So I had to drop the cylinder more than what I wanted. So this will just be my test cylinder for, you know, seeing how far I can grind, and then replicate it on my good one is kind of what I'm thinking. So that's a little bit of an update on this one. I'm curious to see how well that this is going to work. Doing this, it'll be, I haven't seen anyone else that's done it, but I'm curious now that I can get a aftermarket case here, it makes it a lot more achievable of a project to do this. Oh, another thing is I've got my 880 mandrel made. I don't think I've covered this yet. So this is the mandrel that I've made. This is my angle that I'm using for my HSS cutter, which is the main squish band cutting cutter that I like to use, is this one. And I've already got my reliefs here so I can make it a little easier for me to start my drill. I'm just using a hand drill to drill these holes and get it as straight as I can, and that works pretty good. And then this is a carbide insert cutter here. I just took 50 thousandths off here, so this was my high point right here, and that guy's just going to go in here like this. And the purpose for that is to cut out all the chrome that's up here. This should work. I talked to some of my machinist friends and they say that this is my best chance without chucking it in a 4-jaw, putting it in a 4-jaw chuck and doing it that way. So I'm leaning towards this because I've already cut the base of this cylinder. So hopefully this idea works. I'll make an update video when I'm working on this 880 specifically. I've sent out the carburetor on this one to get it bored out so it has more, I guess it's Bernoulli's principle. So if your ODs here of your carburetor are bigger, and then your middle your middle or outer ODs or outer IDs, and then inner ID is the same, but you make the outside larger, you can pull more fuel into the carburetor. And from what this guy told me is that, you know, if you can get more fuel in there, you can get more RPM. So I figured I'd send this carburetor to him and then, you know, see how it does, and then compare this one to my other 880, and that'll give me a clear indication that whether it's better or the same or worse. Because I can just swap the bar, swap the chain, just like I did for my one little stock versus ported 880 video. This one ran a little bit better than the original one that I had. I was not impressed with how the original one that I have ran, so I just went ahead and ported it right away and did kind of a quick and dirty port job. I just raised transfers, raised the exhaust, didn't widen the exhaust really at all because there wasn't a lot of room to widen it with the 3120 piston from the Duke. But now that I've got this Meteor 3120 piston, which I'm assuming is closer to the OEM style piston, should be able to go a little wider on the exhaust. Is really the only change. And I went a little bit more on the intake on this one, and then with that bigger carburetor, maybe this will really be a runner here. So yes, that's kind of a little update of what's going on. The other thing I picked up, since I'm going to be porting a couple saws, is I picked up another pack of these. Pretty much what I'm doing with this is I take the little mandrel holder rod here, I run it in my drill, and then I'm just running it in this exhaust port here, because you grind it but it is not flat. I feel like it's pretty hard to get it flat, so I start with that 80 grit. It'd be nice to get some that are like 60 grit so that I can get that exhaust roof nice and flat, you know, all the sides of the exhaust, you know, as flat as I can, because it's hard to do that with the burr, like, you know, one of these cutters here, double cut, single cut, whatever. So that's what I used for this. This was $20 at Harbor Freight. For all those, I can probably do maybe 3 or 4 cylinders at least on that. And then this helps you kind of work your way up 80, 100, 120, and then I'll do a split mandrel with like 220, and then I'll run the Scotch-Brite here on my little cotter pin split mandrel thing, and that gets it about as smooth as I feel is necessary, just so that it's smooth to the touch. I feel that that's good enough. It doesn't need to be a mirror polish finish. So yeah, I think I took 30 thou off the base of this cylinder. I didn't have to do any more any machining on here. This is just how it came. When you're running a single ring, you can get away with a little bit more out of the chamber. So I was, you know, my other 880 is very easy to start, so I figured I'd take 30 thou off of this one and see if I get a little bit better results. The other thing I did with the 880 for this one is I already cut the intake skirt to get the duration that I wanted, and you know, had to do a little bit of machine work to the piston for it to clear the crank lobes, since this is a 3120 piston and this is an 880. So the 3120 must have a little bit longer connecting rod, I figure. So this is the size of my other 880 is exhaust port, and you can see how much wider I can go. Here's my cut intake skirt here. Still need to sand it up, make it perfect, and then here's my little relief that I did on the exhaust. The theory with doing it this rather than raising the exhaust port higher is that that exhaust, you know, pretty much once that ring goes past the exhaust roof, that's when it starts building compression. So if you can keep that roof lower and do something like this, I feel that that gives better results. I don't have any way, you know, I haven't done a straight up comparison to prove it, but that's just my theory. It seems to have worked pretty good on a couple of saws that I've used this you know, tactic on. So yeah, so that's kind of what's going on. I've been doing a lot of tree work, a lot of other stuff here lately, so that's why I haven't been making as many videos. I'm trying to keep up with at least the YouTube shorts for now. They're a little bit less time consuming than, you know, taking time and filming these videos. Another thing that's nice to do if you're cutting the chambers like I am, what I like to do is I made 2 of these, I guess these are an all thread M6 all threads here, and I just use my little hacksaw and cut a little slot in there so that I can use a little tuning screwdriver to screw them in and out like that. And what that does is it just prevents you from having to screw the cylinder bolts all the way in there, screw them all the way out while you're trying to get the squish right, you know, when you're cutting material out of the chamber. And you'll know that you're there once you can rotate it all the way over and it doesn't lift the cylinder up. Just another little tip. So yeah, so I think I've covered pretty much everything that I'm working on right now. The other saw that I really would like to, you know, add into the mix here is this 400C. I've seen that they respond really well to the port work. I'm doing some porting on it, so I think maybe this one will probably jump ahead of some of these other projects. I gotta wait for this epoxy to set up. I'll probably have to, you know, set it up like this, do this side, maybe get away with flipping it over in one day. Maybe it'll be hard enough so that it won't move when I flip it over to the other side and do this side. And then I need to clean those upper transfers up there a little bit as well. But everything else is done. You know, the exhaust is done, piston's done. So just waiting on the JB Weld to be in here and, you know, cleaning up those upper transfers. I don't know how well this is going to work. I guess worst case scenario is I have to just buy another OEM cylinder and then not go as crazy on the upper transfers as I did on here. So yeah, I guess all of these are all kind of a learning experiment here. So worst case scenario is this doesn't run that good. I pull the cylinder off, get another OEM cylinder and try again. So yeah, so I think I've covered pretty much everything that's going on for now. I'll probably, I guess Sunday I'm doing some tree removal, tree work stuff, so I'll make some videos of that. And this afternoon I'm going to be doing some chain sharpening. I've got a bunch of new chains here. Got a good deal on all these. I like the Stihl chains the most because they hold the best edge. I feel kind of guilty, you know, removing a good little bit of material to get it to be fully square ground, but this chain holds an edge, I would say at least 30% longer than the Oregon chain that I've kind of been experimenting with. So that's why I've, you know, stayed with the Stihl chains. It sucks that they're more expensive, but you just got to be hunting for those deals because I feel that this is the best chain you can get. If you are not cutting the hardwood, you're cutting pine and these softer woods, I feel that the Oregon chain is probably really about the same. That's why the guys on the West Coast are running the Oregon chain, because the wood isn't as hard and it's not as hard on your chains. So if you're cutting a softwood, then stick with the Oregon chain, get the little cheaper chain from like West Coast Saw. I mean, it's definitely a decent price for that. But for the type of wood that I'm cutting, this is what works best for me. Square ground, 7-tooth, drive sprocket. You know, take the rakers down to as much power as your saw has relative to the size of wood that you're cutting is, you know, essentially what I do. I have, you know, chains that I set up just for cutting trees down, because you want the rakers to be less aggressive. When you're cutting trees down, you want that to just be nice and smooth. You're not concerned with how fast that it's cutting, how much pressure you got to put on it. So I'll have one chain that I set up this weekend specifically for cutting trees down, so I just have a nice smooth, you know, process there of getting it cut down, because that's where you want the control. You can just grab another saw with more aggressive rakers for you know, bucking the tree up and all that. So that's kind of a little bit about that. And now that's it for this one. Thanks for watching.